Welcome to this lesson on Rational Exponent Rules, Part 1. Now, you had the rules of exponents in Algebra 1, but what you studied then was very basic, and you probably did not spend very much time on it. On this go-round on exponent rules, you will need to memorize the laws of exponents in order to be successful. So plan on getting that done. Now, let's start with the first law of exponents, the product law. The product law says that when you're multiplying expressions that have the same base, you add the exponents. Now, what do I mean by base and exponents? The big letters, or in this case, the x's, are the bases. And you can see they're both x's, the bases are identical, so I can apply this law, the product law. The exponents are the m and n, and in this presentation I will use the word exponent and power to mean the same thing. So in this case we're multiplying x to the m power times x to the n power, so we can add those two exponents, m plus n. Now, why does this work? Well, let's take a look at this example, x to the third power times x to the fourth power. If I write that out in expanded form, x times x times x times x times x times x, I get x times x times x times x times x times x. That is x to the seventh power. Now, you can see how this is working. If I add 3 plus 4, I get x to the seventh. So, if you're multiplying things with the same base, you can add the exponents. Here are a couple of more examples. If I multiply x to the second power times x to the sixth power, I can add 2 plus 6, and it ends up being x to the eighth power. That is the product law of exponents. Pause now and copy everything that you see on the screen now. Next is the quotient law of exponents. Now, as the word quotient suggests, we're talking about division here. If we are dividing two expressions with the same base, I can subtract the exponents. So you can see this is very similar to the last thing we looked at, only this time it's division. Now, why does this work? Let's write it out in expanded form. And you see we have 6 x's in the numerator and 2 x's in the denominator. We can cancel out 2 of the x's on the top and the bottom and wind up with 4 x's. That is x to the 6 minus 2 power, or x to the 4th power. That is the quotient law of exponents. Now here's an example. X to the 8th power divided by x to the 3rd power is equal to x to the 8 minus 3 power. We always subtract the power in the denominator from the power in the numerator, and we get x to the 5th power. Pause now and copy down everything you see on the screen. The third law that we must know is the power of a power. Now, here we're talking about you are raising a power, in this case m as in Mary, to another power, n as in Nancy. So when we do that, we're going to multiply the two exponents. Now, again, why does this work? Let's take a look at this example. X squared to the 4th power. That means we're going to have x squared times itself 4 times. And if we have that, then we can apply the product rule of exponents, the product law, and we can add all of those exponents of 2 together. And when we do that, we end up with x to the 8th power. So you can see, in fact, that x to the 2nd power, all raised to the 4th power, is x to the 2 times 4 power, or x to the 8th power. That is the power of a power law of exponents. Now here's another example. X to the 3rd power, all raised to the 5th power, is equal to x to the 3 times 5 power is equal to x to the 15th power. Please pause now and make sure that you have all of this written in your notes. Now there are a few other things that we need to go over in this Part 1 presentation on the properties of exponents. That is, what happens if you're raising an entire product to a particular power? In other words, we have something like x times y. That's a product because we're multiplying them to each other. What if we're taking that whole thing and we're raising that to the nth power? Well, you distribute the power across all the terms in your product. In this case, we would end up with x to the nth power times y to the nth power. So this works kind of like the distributive property. Now, why does this work? Well, if we take a look at x times y to the 3rd power, and we write that in expanded form, then we end up with x times y multiplied by itself 3 times. Well, if we rearrange those letters to combine like terms, then we end up finally with x times y. Well, that's definitely x to the 3rd power times y to the 3rd power. So we see that we can just distribute the exponent across the product, and we'll get the right answer. That is the power of a product property of exponents. Now here is an example. X times y, all raised to the 2nd power, is equal to x to the 2nd times y to the 2nd. Pause now and make sure you have everything you see on this screen in your notes. Okay, let's talk about the power of a quotient. Very similar to the power of a product, only this time we're talking division. We're dividing 2 terms. They don't have to be the same base. They could be completely different terms. And we raise that whole quotient to a power, then we distribute the power to the numerator, every term in the numerator, and every term in the denominator. Now, let's look at why this works. Well, we're going to, as always, write in an expanded form, and then combine like terms in the numerator. And we see that we have x times itself 4 times in the numerator, and y times itself 4 times in the denominator. So we end up with x to the 4th divided by y to the 4th. That is the power of a quotient rule. Now here are 2 examples. In the first example, it's very simple. We're simply going to distribute the power of 7 to each term in the numerator and the denominator. But in this simple case, there's only 1 term in the numerator and 1 term in the denominator. What if the numerator already has a power? Then we would apply the power to a power property, and we would apply that to each term in the numerator and the denominator. We're going to distribute that power of 4 to x to the 3rd. When we do that, we're going to multiply 3 times 4 and get 12. And then we're going to distribute that power of 4 to y to the 2nd. That means we have y to the 2 times 4, which is y to the 8th. Pause now and copy down everything on the screen. Now, you very rarely have a situation where you just need to apply 1 rule. Usually, you need to apply multiple rules in order to completely simplify an expression. So I want to show you a couple of simple examples now, and we'll do some more complicated examples in class. Here's the first example. We have m to the 7th power divided by m to the 3rd power times m to the 4th power. Now, the first thing we're going to do is apply the product rule of exponents, the product law, which says that when we're multiplying 2 exponents that have the same base, we add the exponent. So right now I'm going to focus on the denominator, and I'm going to apply the product law and add those 2 together. So I'm going to end up with m to the 7th power in the denominator. I have the same thing in the numerator, and so this simplifies to 1. Pause now and copy down this entire example. In example 2, we have 40 times x to the 3rd times y to the 2nd divided by 8y, all raised to the 3rd power. So what are we going to do here? The first law we're going to apply is the power of a product. We are raising more than one term to a power, and so we're going to distribute it to all of the terms. And we do that in both the numerator and the denominator. Now, we could have called this the power of a power law. We could have applied this as the power of a quotient law. I just chose the power of a product. Either way, I have to take that power that is outside the parentheses and apply it to every term in this expression, including the numbers. So you can see I raised 40 to the 3rd power. And then, because I'm applying a power to a power, I multiply these two exponents, x to the 3 times 3, and then y to the 2 times 3. I also apply that 3rd power to the denominator, 8 to the 3rd power, and y to the 3rd power. I distribute it to every term in this expression. Now, next, I simplify. So, I'm going to go ahead and do this multiplication, and I'm going to end up with 40 to the 3rd power, x to the 9th power, y to the 6th power, all divided by 8 to the 3rd power, and y to the 3rd power. Now, I'm going to apply the quotient law of exponents. Anything that has the same base, I'm going to subtract the exponents. Well, 40 and 8 aren't the same. There are no x in the denominator, so I can't do anything with that. But I do have y to the 6th and y to the 3rd, so I can subtract those two exponents, and I can multiply out 40 to the 3rd power and 8 to the 3rd power. So when I subtract these two exponents, the y in the denominator goes away. So now, if I just simplify this expression, I get 125 times x to the 9th times y to the 3rd. Pause now and write down everything you see in this example. Now, I want you to take a careful note. In anything you did not understand, note that question, come to class ready to ask questions and to apply what you have seen today in this presentation. I'll see you in class.